All right, hey, great. So it looks like it's working. So, greetings everyone, and welcome to the next session in the IlliniCloud webinar series. This series is going to be focusing on E-Blox, educational toys designed to teach STEM, STEAM, and STREAM. Folks that have joined these webinars in the past know my name is Jack Panu. I'm Business and Operations Lead for the IlliniCloud. And joining us today is Dr. James Seymour. Even though he says, don't call me doctor, I'm going to call him anyway. Dr. Vic, VP and CTO of E-Blox. This is an interactive session, so as folks join in, please submit your questions to the chat or feel free to voice them during the session, and we'll either take them in stride or kind of queue them up for the end. As a reminder, IlliniCloud webinar series are every Wednesday at noon Central Time, given that there's things scheduled. If you're curious about what's the upcoming webinars or would like to participate in a webinar, just let me know, and I'll be happy to get you on the schedule. With that, Jim, please feel free to introduce yourself, and share your screen is already shared, so let's get started.
Okay, great. Thanks, Jet. My name is Jim Seymour. I'm one of the co-founders of E-Blox, which is a new startup company. We incorporated just last year and just launched our first products in March. Our focus is on educational toys that teach the fundamentals of STEM, STEAM, and STREAM by encouraging children to learn by building through construction toys that add electronics to it. Okay, so I just had one slide here with a little bit of our background. We are based out of Buffalo Grove, Illinois. As I said, we launched December last year. We're a family business, but even though we're a startup, we've been in the toy industry for a long time and have over 90 years of combined experience in educational toys and the wireless industry. Our vision was always to take one of the greatest toy inventions out there, which has been Legos, and to enhance upon your Lego experience while making them educational. That's really been our vision. And so the products that you'll see here today, I think we have now gotten to the point where now it's our mission, to make these fun products that can provide education, through STEM, STREAM, and STEAM fundamentals, through electronic construction building set toys. Okay. So we have three product lines. They're shown on slide 3 here. Our first product line, Circuit Builder, is our STEM product line. It's our most educational product line. It's based on sort of Duplo size type of Lego parts, where you can build circuits that do fun things like have fans launch, have lights go off, make sounds, and you learn about electronics while you're building these fun circuits. Our parts product line is our STEAM product, and in this product, this is where we add electronics to classical style Legos and encourage your artistic creativity in not only building cool things that light up, but also in how you build your three-dimensional circuits into your builds. And so it adds the arts to STEM, and that's kind of in the name of the product line and why we call it parts. And then our last product line is Stories. This adds the reading and writing aspects to STEAM. And this is where we provide a story where now you're encouraging the kids to read. And in the story, you encounter characters and objects that you can then build with your electronic E-Blox parts that make them light up, and in the future will make sounds and motions. Okay, so, and by the way, if there's any questions, I'll look for that in the chat, or you can ask them on the line as we go. So first we'll start with the Circuit Builder set, which is, as I mentioned, our STEM product. And even though we launched in March, we've already received a couple of awards on this product from Creative Child magazine. That's on our Circuit Builder 120. And so we have 3 products in this line, and they each come with a manual with between 59 to 120 projects that teach you about electronics and do fun things while you're building these circuits. Slide 5. Here we show the basic parts that you get with these sets. You get a subset of these parts in each set. They all come with a base grid for putting the parts on to sort of hold them in place and make the connections fit well. You get a battery module that requires 3 AA batteries to provide around 4.5 to 5 volts. You have some parts that act like your wires to connect the battery module to your other parts to power them. And then the other parts are things like LED modules that can light up hearts or stars or change colors to light up a fiber tree. Motors and fans, so a motor that can spin a fan and launch it in the air. Alarm modules that make whistling sounds. Music ICs that can make space war, sirens, and music. And even an FM receiver and amplifier so that you can receive FM radio channels over the air and play them on a speaker. And then, of course, we include a bunch of switches so that you can turn on and off your circuits or change functions of your circuits. Okay. So slide 6 kind of shows you how this product works. It's all based on a pin connector technology. On the left there, you can see there's sort of pins that point out the top of the modules and then pin receptors on the bottom of the module, so you can plug them together and it makes a good connection so that now you can actually build circuits like shown on the right, a sample project on the right where we connected the battery module to the heart LED and then through a couple of switches, all of this being in series, so that now when you push both of the switches down, it lights up the heart. And in the middle, we show one page from our manual that shows another example project. This one being one where you may have a press switch in series with a parallel combination of a star LED and a motor that's in series with a lamp. And you can see as you get to circuits like this, you can have a lot of different combinations of putting the switches and the parts in series versus parallel and create a wide range of series parallel connections that all, help you learn about electronics and how you best enable the various components in these sets. So just a few things now. I was going to talk about how you can use this product to teach the fundamentals of STEM in the classrooms. First, you learn about circuits, and that in order to have a circuit work, you have to have a closed path from the voltage, so 4.5 to 5 volts coming from the battery, all the way to the ground on the battery. And so you learn very quickly in the early parts of the manuals to create closed loop circuits that allows the current to flow from the 4.5 volts through your components and then back to the ground. And some of the components, like the LED modules, have polarity. So you need to put them in the right directions. They have, they teach about diodes and how they're directional. And so you put them in the right way and they work. If you put them in the wrong way, they don't. And so you're learning about the polarity aspects of certain components in the sets. Then, with the switches, we provide 4 different types of switches. Some are just press it and it's on, press it again, it's off. Some you hold down to be on and you let go and it's off. The reed switch is like a magnetic switch. So you put a magnet near it and it closes it so that it's a short, and then you take the magnet away and it opens it. And then there's a touch plate, which has 2 leads on it, where if you provided a metal connection between that or something highly conductive, it would actually create a short. But for high input impedance things like the music module inputs in the set, you can actually just lick your fingers and it can enable certain functions with just putting your finger on the module. And so with these switches, here's one example on slide 9 of the kind of things you can teach, real world experiences with switches. We have in one page of our manual an example where you have 3 of these switches that are in series versus putting them in parallel. And what you see is that when you push, turn all 3 switches on, you need to turn all 3 switches on in order to enable the lamp to light up in the top circuit, versus when they're all 3 in parallel, any one of them can be pressed to light the lamp. And so this is kind of an example of why in our homes, when we have multiple switches in a room, they're designed to be in parallel because you don't want to have to go to every switch in the room and turn it on before your light goes on. And so there are various combinations of these parallel and series circuits that are taught in the manuals. Another example of something you can teach with this set is the fiber optic, the physics of fiber optics. Here, it's a little bit hard to see in this picture, but what I'm doing in this picture is my thumb is holding out one strand of the fiber tree there. And the tip of it, you can actually see, is lit up, which is showing that the light that comes in one end of the fiber is actually traveling and reflecting, off the glass in the fiber all the way to the other end. And you could actually create sort of fun class experiments where you create a code, like maybe use Morse code, and one person at the end is hitting the button to hold the light down on for certain periods of times to, send a code over that fiber, and another person on the other end actually decoding the message. So this is yet another practical example of, technology, fiber optics, that's used for like your UVerse or FiOS technologies that you may get from your service providers. The motor on slide 11 here is another fascinating component that really provides a lot of educational value. In addition to being probably the most fun component in the set, because the kids just love to launch the fan, way in the air. They can play with that for hours. But then learning about just how a motor works, about how we take, when you put an electric current through a magnetic field, how that is what actually creates the motion in the shaft. And you can actually demonstrate Fleming's left-hand rule, where if you look at the middle picture in this figure, if you consider the current that's going in a downward path next to the red square with the N in it, and put your middle finger in that direction, and then the magnetic field is going from north to south, and so you put your index finger in that direction, and you see your thumb points up, and so that pushes that wire in a clockwise direction, and that is what actually makes the motor spin. And so you learn about how, all motors have these magnets in them, and then when the current, when you set up your circuit, you put current through there, and when that goes through that magnetic field, that's what spins the shaft of the motor. So just another example of what can be taught with this set. And then one more final example is the FM receiver module that we have in the set. It comes with the orange block there that is the FM receiver with an antenna port, and then outputs the audio signals and has channel selection pins to connect to. And then the output from that module is low amplitude. So you go through an amplifier module that you can then hear the signal on the speaker that's provided in the set. And there's a volume adjust that goes in between the two. So you can build that circuit that's shown there in the lower right and actually receive FM radio signals over the air. And even though we may think, not a lot of people listen to FM radio anymore, when you build it yourself, you tend to want to just listen to it all the time because it's just kind of amazing you can build one of these things with just a simple set of parts. And then, on the next slide, slide 13, we show how you can actually, get into some of the theory on how AM and FM radio works when you have a set like this. There are towers out there transmitting these signals in the AM band between 540 and 1600 kilohertz, and in the FM band between 88 to 108 megahertz, and get into the theory about how amplitude modulation. That's an easier one to kind of see in a picture here, where the music signal is sort of modulated onto the amplitude of a high frequency carrier. The FM receiver, which is what is in the set, you can demonstrate easier with like a tone to see when the tone is at a high level, then the frequency of the carrier wave is high, and then when it's at a low level, it's at a lower frequency. And so again, just another way you can be introducing a fun product into the classroom, but then teach very educational aspects about how AM and FM radio communication works. And in addition to showing the things that you can do with this, You can also demonstrate the things you're not supposed to do, like create shorts in your circuit. Our battery module is designed so that when you do create a short, there's a red light that flashes, okay? And in the future, we're actually going to add beeping to this too, so that you'll hear it. But right now, the red light flashes, and there's also a fuse in the battery module so that you don't actually short the batteries and drain the current that would, drain the batteries and don't get them hot, okay? So anything that you do in your circuit that would lead to drawing more than, say, 400 to 500 milliamps will cause that fuse to trip, protecting your batteries, preventing any kind of damage or things getting hot. And as soon as the short is removed, it's a resettable fuse, so it goes back to working fine. Okay, so that was the basic overview of the circuit builder product, which is our STEM product. I'm going to move on now to our parts product line, which is our STEAM product. This also, even though we launched it in March, we've already received a Preferred Choice Award from Creative Child Magazine on our Parts Plus product. Now, this product is one where we've introduced electronics into classic style Legos. Okay, and by the way, I say Legos, but really we make our own parts, but they're fully compatible with standard Legos. Okay, but we introduce electronics into some of these components, and we plate some of the parts so that they're conductive and they can kind of act like your wires. Okay, and we'll show that in the next few slides. But in terms of our product line, we have various sets here depending on just how much you want to spend and how much you want to get and be able to build. The more parts you get, the cooler things you can develop, as well as whether you have a lot of standard Legos at home or not. If you do have a lot of standard Legos at home, then some of our products along the bottom here, the Standard Advanced Pro, provide you just the plated parts, the LEDs, and the battery module, versus if you don't have a lot of Legos at home, then the Plus and Deluxe add some of the non-plated parts so that you can build cool things like mermaids, robots, and dogs and cats whose eyes light up. Okay, so on the next slide, we show here what's the general building blocks of this product. Again, there's a battery module. In this case, it's a 9-volt battery that would go into this module that's shown there on the left. And the terminals of the 9-volt battery are connected to those two terminals on the top of the module shown there. And they're labeled, the plus for the 9 volts and the minus for the ground. Okay, so that provides the power to, the voltage to power your circuits. Then we plate some of the parts. We plate them in tin. Tin is a highly conductive material. We've actually, by plugging these parts together, like 300 of them in a long string, we've actually measured less than an ohm of resistance. Okay, so very good conductivity as you connect these parts together when they're plated in tin. But tin is also a very safe material. All of our food comes in tin cans. So if kids lick these things or something, there's not going to be any safety issues with plating these parts. And then we created an LED module. The LED module is shown there up on the right corner. In this module, it's one component that's connected together. It looks like multiple sort of Lego parts, but it's actually all designed to stay together as one. The bottom base part is plated again in tin, but then we laser cut through the middle so that, and then we screw in an LED, one lead to each side of the laser cutting, so that now when current comes in one side, it's actually forced to go through the LED to get to the other side. And when current passes through there, that's what lights the LED up. And in these modules, we place various types of LEDs. Some of them, they have different colors, red, green, blue. Some of them are on all the time. Some of them flash, so red, green, and blue flashing. And some of them we call RGB. They change colors over time. So on slide 17, this now demonstrates how you can use these parts to create three-dimensional circuits and light up your builds. So the basic idea is you take your plated parts, they kind of act like your wires, and you can connect them to the battery terminals and create circuit paths to wherever you want to light up your LED. And so you can kind of see in the second figure there, the current path goes from the 9 volts of the battery module through the LED and then back to the ground of the battery module. And again, completing the circuit is what then makes your LED light up. In this set, you also find that when you put just the LED next to those plated parts, it doesn't always cause a good connection. They're side by side, but flat side by side doesn't provide a very good point connection. So a lot of times you won't find that that'll provide a good enough connection to light the LED. But you can basically put other parts on top, like shown on the final figure there. So the up-down connections are always very good, and that's how you basically create these paths, and can continue connecting plated parts together to create long paths to reach wherever you want to light up your LEDs. So on slide 18, we again show some of the educational aspects now that can be demonstrated with this set. The first thing that's always fun to play with this is to put in those long 1x8 plated parts and then put a bunch of LEDs in parallel across it and have all these LEDs of different colors light up. And it looks really cool when you do that. Because in parallel, they are the brightest, but they also draw the most amount of current, okay, so when you put the things in parallel. The middle figure shows you can look at putting these in series, but now again, getting into sort of the math and educational aspects of electronics, every LED has about a 3.3 voltage drop across it. And with a 9-volt battery, you can see that when you get up to 3 of these LEDs, you may not be able to light all of them. Maybe only 2 of them light, or maybe none of them light, depending on exactly how much that 9 volts is split across each LED. So one thing you can do is, that's with a single battery module. You can obviously put multiple battery modules in series and get like 18 volts, and then you could get up to like 5 LEDs in series. And again, the purpose of trying to do some things in series is that it reduces the amount of current draw. So you can look at like the figure on the right. Here's where we actually have 4 parallel combinations of 2 LEDs each in series. And if you compare the current draw of that to putting just 8 LEDs fully in parallel, it's actually 1/4 the current. So your battery, you can light up 8 LEDs now, and your battery will last 4 times as long. Okay. So again, these are the kind of things where you start to just playing with these things and making your things light up for the longest period of time is teaching you about some of the fundamentals on how electronics work. And of course, just like with Circuit Builder, the battery module is designed to be safe. It beeps at you whenever it draws too much current or is shorted, and that's around 400 to 500 milliamps. And again, there's a fuse in there that protects the 9-volt battery from actually getting shorted and getting hot. Okay. So that's kind of the educational aspects. This is our STEAM product because it encourages artistic creativity in how you use these parts to build really cool things. We provide a sheet that explains everything that I explained on how the set works, and online we actually have some sample builds. But other than that, the sets are really encouraged for the kids to come up with their own creative builds, what they can do with this, and create their own creative 3D circuits. And the middle here of this slide shows some of the really crazy master builds that we've had fun building with these things. Being from the Chicago area, we're clearly Blackhawks fans, so we started with that one. And even Federated Rate Field, Sox Field there, a replica of that, we've built. You can see the Statue of Liberty. We were at a Washington show, so we did the helmet for the Redskins. And on the right there, we've actually built like a 5-foot tower, that blue one. That one actually is powered by 2 battery modules, so providing the 18 volts. But because there's 360 LEDs in there, but we still draw only about 300 milliamps and can light that thing up with just 2 battery modules. So
hey
pretty
Jim,
cool stuff.
looks like Jason's raising his hand with a question.
Oh yeah, sure. Go ahead.
Hey, Jim. Can you hear me okay?
Yeah.
Yeah, so I had one question and one comment in your presentation so far. So I know that there's a lot of products out there on the market that sort of do some of this that, teachers get inundated with. And they have, of course, greatly varying degrees of cost involved and complexity. What kind of do you feel your product is, is the advantages in, offering, something for teachers?
Right. So the first thing that is unique about our product is that, you may see lights and stuff lighting up Legos other areas, but at least when I go around to shows and see that, every time I look at it, there's always a wire, okay, that's connected there. And in our case, there's no wires, okay? Everything is just based on the plated parts, and the battery module. And so that's one advantage. And we've spent many, many years in the plating process in order to make that cost effective. That's not an inexpensive process, and is why you don't find a lot of Legos out there that are plated. But we've spent many years optimizing that process to make it cost effective. And because we've done it this way, you can do some of those things, like I said, with that tower, where you could have 360 LEDs powered by just 2 battery modules. That's something that some of those other sets, I think, would have a very challenging time doing without a lot of expense.
Yeah, and that's actually one of the things I noticed when I was looking at just, the MSRP of your product is it's drastically more cost effective than a lot of other, products out there on the market. And my follow-up comment is, in kind of listening to sort of the STEM and STEAM portion, is there's a big continuum here where this looks like it's sort of, younger kids, introduce them to electronics and building. But as I'm thinking through and looking at, like, for instance, your motors, there's opportunities to possibly introduce, when math teachers are teaching about, the polar coordinate system, how to control, or for instance, you had the LEDs or the AM and FM modules that actually gets into some things like, sampling, resolution, transforms, right? Whether you're teaching, how does Fourier or crosswork or in higher order math. So it looks like you can actually take these and really inexpensively apply them to lots of advanced curriculum that teachers are doing.
Absolutely. I just gave a few examples there, but you're right. You're totally right. You can go as far as you want with this stuff. And the thing is, when you bring something physical like that, like an FM receiver there, and then get into all that stuff, it's just the interest level of the kids just goes way up, okay? Because they can see it, they can feel it, and then they're more wanting to understand it, right? As opposed to just slapping all those math equations down and having them fall asleep, right? So absolutely, it's 100% agree.
Thank you.
Okay, so also these master builds are ones that, that aren't in any of our sets. We've used a lot of our parts to build them, but some of the things you see in the top corners and the bottom corners are actually in our sets. So that heart, or the cat's who eyes light up, or the flashing frenzy kit has that castle that's lit up. Those are the kind of things you can buy in our sets. And then, of course, you can always buy multiple of our sets to build, huge master builds like this that are cool. And slide 21 just shows that even though we've started with LEDs, we're still fairly young. We launched in March. And so there's a lot that we're going to be adding to this line. We're going to be adding the resistors, capacitors, diodes, inductors. We even, those can easily fit in our modules that currently have our LED in it. But then we'll be building some bigger modules for the transistors and motors and, audio effects modules and stuff like that. So there's a lot more to come in this stuff where you can teach more advanced RC circuits, robotics, that kind of stuff. That's all going to be coming in the near future. Slide 22 here. And by the way, chat, when I'm in screen share mode here, I don't see the hand, so interrupt me if you see some questions come up. Okay.
No problem. Thank you.
Yep. So this slide 22 just shows that these two product lines that I discussed, the circuit builder and parts, actually can work together. One of the great things about Duplo was it was designed to be exactly twice the width and twice the length of classic Legos. So they actually plug together. And we designed an interfacing part so that if you just have your parts battery module, you can actually use that connecting pin there that's plated. The pin is connected to the outer plating. So now when you hook that up to the battery module, it actually powers the pins and you can power your circuit builder components. So this is just demonstrating that you can actually work these two product lines together to build even more creative things like a Lego structure that has the fan and LED heart and stuff on top of it. Okay, on the last 20 minutes here, I just want to spend on the E-Blox Stories product line. This is our Stream product, and Stream adds the reading and in fact, we even add the writing aspects to it. Writing at least has an R in the second letter, so we think that counts too. And so here we have 3 products, and the idea here is to add a story to this set, encouraging kids to read. And now as you read through the story, you'll encounter objects and characters in the story that you can actually build in the set. So on this slide 24 here, we show this is an example of the island story. And you can see there, sort of in the middle, in the top, you're reading through the story, and then you may encounter like a robot in the story. And then there's an assembly manual that shows how you can build the robot whose eyes light up. So again, you know, providing the STEM aspects of the electronics and how you can build 3-dimensional circuits into your build, but also now encouraging reading. And even beyond the reading, we include QR links into the story here, so that now when you encounter that robot, we have a QR link that takes you to a NASA site and teaches you about robotics. So encouraging more reading and encouraging more education in areas, you know, that are interesting. And it can be beyond electronics and engineering, even STEM issues. Like in this story, there's a Devon cat named Devon that, you know, there's a link that teaches you about the history of Devon cats. So this concept, and with the QR codes, now you have a means of actually teaching in any area, even beyond STEM, with these types of products. And here's just an example, this slide, of the 3 stories that we have of some of the areas that the QR links take you to teach you about. So we mentioned robotics, but marine biology, metaphysics, laser technology, you know, microchip technology, learn about architecture, biology. I mean, huge range of areas here that are taught in these stories. And then to add more of the artistic creativity as well as the writing aspects, we're going to be coordinating a contest. Once, you know, we get, you know, a little more sales of these and there's enough people with these products in their hands, there's a unique code in every set that allows you to submit your own writing a chapter of the story with your own build, and it allows you to vote on the contest. You can vote for yourself if you want, but we'll take all these inputs, look at the coolest new chapter of the story, the coolest new builds, you know, give out some awards. But also the great thing is, because everybody who buys these sets has the same set of parts, we'll be able to post the winners, and anybody who has the set will be able to build those cool things in the new chapters of the story. So again, adding, you know, the writing aspects, making this even more Stream, adding the artistic creativity to writing, you know, your own story. That's what really makes this product a Stream product. Okay, that pretty much covered what I had to say here today. And so just in summary, E-Blox, you know, is a new company, and we have plans to become one of the leading educational electronic toys companies in the industry, focused on providing products that teach the fundamentals of STEM, STEAM, and Stream, engaging kids to learn by building through electronic construction toy sets. Our Circuit Builder line is our most educational STEM product based on project manuals that teach you about electronics by building cool circuits that do things like launch fans, light up lights, and make sounds. Our Parts product line is our STEAM product line that adds electronics to Lego types of construction sets, that encourages the artistic creativity in building cool structures, as well as the artistic creativity in building three-dimensional circuits into your builds. And then our Stories line, as we just discussed, adds the reading and writing aspects to that, introducing a story where you can build the characters or objects in the story and even write your own version of the story in a creative fashion. And so just encourage people to visit our website at www.myeblox.com to check out all of our cool products there, and start using it in schools to teach all these cool areas of STEM, STEAM, and STREAM.
Great. Thank you so much for that, Jim. A couple of remarks I'd like to make. Number one, so E-Blox and IlliniCloud are working together and in forming a partnership where a lot of these great types of different configurations for E-Blox will be available at very affordable and reachable prices for school districts of any size. So stay tuned for seeing more on that front. We've got a little bit of work to do on kind of formalizing the agreement, but it'll be something that really makes E-Blox something that is easily engaged from both a curriculum perspective, but also from a financial perspective. So stay tuned for that, and you'll see various different communications come out about that. Additionally, one thing I'd like, Jim, you to talk to, you've covered a really broad spectrum of various different things, which I think was very, very informative to everybody, including myself. What are kind of the grade levels that people should start with when kind of engaging with E-Blox? And, you went from all the way from, basic connectivity to, advanced motors and brush and brushless to, to physics and fiber optics. So it's a pretty broad spectrum in the kind of the STEM and STEAM area. Where's a good place to start?
Right. So on all of our products, we advertise ages 8 and up, which, I guess would mean like 3rd grades and up. But, part of that is the fact that when, if we advertised any, like 5 and up, which is what we really see kids starting to play with this. So even kindergarten to 1st grade, then the 8-year-olds wouldn't actually buy the sets because they don't want anything that says 5 and up. So we really see that ages 5 and up start engaging. So, in the primary school grades, you can start engaging. And then it really depends on just, the kid's interest. I mean, kids well beyond 8, use this stuff to build, like myself, build those master builds. So it can really go up to any age. I mean, all this stuff, if you're working, in a robotics club that, in high school that uses Legos, you can add to your Lego sets, right, with lighting it up with our components, because it's all fully compatible, with Legos. So I would say the starting point is, kindergarten, 1st grade, but it doesn't end on the upper level.
Fantastic. Great. All right. Well, Jim, thank you so much for your time today and sharing with us the great stuff that you're doing there at E-Blox. And, I will send out a follow-up in terms of how to get connected with Jim and for folks that are interested. And it'll also be posted to the YouTube channel with Jim's contact information. So please don't be shy and reach out to Jim if you have any additional questions or interested in doing something with E-Blox. Thanks again, Jim.
Great. Thank you, Jet.
Yep.
Thank you.
Bye.
Bye.